Uh, Before we left for lunch and a break, we have talked till this open or restricted environment, what kind of environment we are going to work, uh, and what are the pros and cons of using different environment. If it is on open, what are the pros? If it is restricted, what are the pros and cons? We should know and decide that what kind of environment we want to work on it. Okay. After deciding the environment, then there is one thing which comes is controlling the variance. How to control the variance? Suppose there is a study in which 50 participants are taking part. Now, and I want to see a new system, whether system A is better or another. So we have talked about open and restricted, and then we have to control the variance. What do we mean by controlling the variance? Suppose 50 students or 50 participants are taking part in a study. Now their expertise, their background could be different. And we want to have two sets. Maybe I want to divide 50 students, 50 participants in two groups, 25 in one group for study and 25 in another group of study. So I have to make sure that those 25 participants which I have in both the groups, they are almost similar. They have similar type of background. To do this, we normally try to, suppose I want to work on a project or a study in which the participant requires the knowledge of Python. Okay. So what would I do? One possible thing is using a self-assessment as a tool. What we mean by self-assessment, I ask all the participants to write what is their expertise in Python. Maybe they write, and I give them three options: basic, intermediate, or advanced. Okay, this is one way of judging. Another way of judging is, but normally when we do a self-assessment as a tool to obtain an understanding of the participant level of exercise, this information may not be reliable. Some student might say that he is of medium level, but as an expert, I feel that he's of basic level or he's of advanced level anyway. So in such kind of a thing, normally we can have a small kind of a test kind of a thing to see the ability of the participants, depending upon what kind of expertise I need, and then try to divide them in same kind. Or sometimes we can also take some previous examination which they have given earlier, and we can see how was their performance in that previous test, and that can also be taken. So this is how we try to control variance in the empirical studies, because that is very important, because result would be dependent upon, if we will have variance in the groups, then this would be different. So this is what I mean by controlling variance while doing the experimentation. So normally in these kinds of studies, we do in the universities also. Okay, please repeat, you missed. Okay, I repeat for a minute. I go to back. Controlling variances from where I started after the break. Controlling variance means having same type of participants in both the group. I gave the example, if I have got 50 participants, then 20, and I make them divide them in two groups, 25 participants in each group. Then the expertise which is required to do that experimentation in both the groups should be the same. And to check that, one of the method using is that using a self-assessment tool, that I can just ask the students what is your kind of, maybe I need for Python, and I ask them what is your expertise in Python, and ask them to give answer in basic, medium, or advanced level. But when we use this kind of self-assessment as a tool, we have found that normally sometimes it is not that reliable, because somebody might say he's of a medium expertise, but actually might be an advanced or might be of a basic level. So what to avoid these kinds of variance, what we do, we can give them a small kind of a test, small kind of an exercise before doing the actual experimentation. to check their knowledge about the requirement for that experimentation. And then we try to divide them 25 students with the equal kind of expertise. If there are in one group there are 5 persons with high level of expertise, in another group also we try that there be 5 persons with high expertise, medium. So we try to divide this. This is called controlling the variance. Otherwise, the result depend upon the kind of subjects we have in our experimentation. So these experimentations also are done as students. Sometimes we take students as participants for these kinds of expertise, because many of these researchers go in universities. And in universities, the best sources we have students as our subjects. Easy way to get the subjects, because it is otherwise very difficult to get subjects for your experimentation. So students are used. And when sometimes you publish your work, they do an objection that whether students were well qualified to participate in these kinds of experiment or not. In that case, we make sure we see the experience of the students. We also ensure that they understand that they are participating in a research study. Another thing we do that we give them some motivation. Maybe we give them some grades for participating in the research project. They understand the research project, and and also they get some grade for doing that kind of a research project. So they are motivated to participate. I'll try to. I'll give this now in brief so that we can reach to the next topic. So this is about instrumentation, that what all is required for experimentation. Some study objects, maybe some software is required on which they have to work. So we make them familiar with the software. Some guidelines are to be given that how you have to participate in experiment. Then some measurement instruments are given, maybe some tool, and they should be familiar with the uses of that tool to gather the data. And then we evaluating the proposal. So this is something which is obvious. I am not going into much details. I want to go to the next topic. Okay. And then there is an important thing about this. Whenever we do an empirical study, share your artifacts to allow reuse by other researchers. So whenever I collect a data, nowadays good journals would make it compulsory that I share my data, or otherwise there are, you all know, you must be knowing about GitHub. There are certain platforms where I can share my data so that other researchers can also work on that data. Because collecting a data is a big thing. So we have open source repositories where we can get our data published so that other researchers can use. They have they check that the data which you are sending to them, they meet a certain level. And if they meet that level, that is in that repository you can deposit, and so other researchers can work on that data, and then we can have generalized results. As I said, doing one study on a data might not suffice as from statistical point of view. So it is very important to do repeated studies by different persons in different environment, and maybe on the same data or using different techniques. So it is always good to share your data, share your artifacts with other researchers so that they can also come up with their reports, results, and then we can generalize those results. One or two studies cannot generalize the results. I hope this is clear to you. 2-3 yes would be suffice. You have understood why we should share our artifacts. Simran says yes. Would they also? Yes. Thank you. So then we have certain guidelines and other materials we provide them. Provide them examples of expected output. We also provide them some test guidelines, templates, tools. These all are provided before starting the experiment. And we also do some kind of training, not on the training, on the similar kind of a thing, so that they are well versed with the kind of environment they are going to use. So for operation, we have to define a baseline, we motivate, train them, and give them a limited time frame that in this much time frame you have to do your work. Now comes another thing. Now suppose I have collected the data. Now comes till now we have been emphasizing that how we have to do this experimental setup, how we have to do the scope of our study, what is going to my research question, and then I have to collect certain amount of data. Once I have collected data, so now we need to understand that what type of problems I get once I gather the data. There are different kinds of problems. One of this, as is mentioned over here, there is dealing with outliers. When you see the data normally would be in certain ranges. Okay, suppose for a particular variable, suppose variable one, the data is ranging from 0 to 500, say. Okay, so data is ranging from 0 to 500. Now I really need to analyze my data, that whatever we have collected, is it correct or not? And I find that there is some reading which is giving me a value like 5,000. Okay, so this I really need to look into, analyze that value, whether actually the value could be 5,000 or it is some kind of an error or something else has happened in the system. It might be possible that while there is some kind of an error, it could have been 500 by mistake. It is by collecting from the whichever software or tool I am using, it has been made 5,000, or it could actually be 5,000. So that is why I was saying earlier also that it is very important to understand your data. It is not about giving some data to a tool and getting something out of it and publishing the result. So you must understand your data. If my formula for calculating the attribute V1 says that the value cannot go beyond 500, so obviously 5,000 cannot be an answer. But it might be possible that value can go up to 5,000. It might be a true value, and some kind of changes, something happened in my system, because of that the value has come out to be 5,000, and so it might be a critical value also. So you do not have to take it out just considering that because this is an outlier. So sometimes, many times when we give to the students, so what do? They say, ma'am, remove the outliers. Why did you remove? I don't know. Did you read what is this data? Don't know. Do you know how this data has come? What is the formula for finding this data? No. So it is very important to understand your data, know each and every attribute if you want to do a good analysis, and see if it is actually in an outlier because of some mistake it has come. You can remove it. If it is an actual data, you have to be more careful about that data, because that might be giving, because if suppose I am taking network traffic and immediately network traffic increases, so am I removing that considering it is an outlier, would mean that I have removed a very important data. It was not an outlier, it was indicating me that some attack has occurred on my system. That is why immediately the data packets has increased. I think I have made my point clear. Yes or no? Any doubt? Please,
Yes, ma'am.
I'd like to see in the chat. Uday is saying yes. Jai is saying yes. So now Gopesh is not. Okay, Gopesh is saying no. Gopesh, whenever you collect data, the next step comes, we call it as a data cleaning step. In data cleaning step, we look at the data and want to see there could be certain problems in the data. One of that problem, which I have discussed just now, is that outlier. Outlier is a there could be outlier could be a value. Suppose my values are, as I took an example, are between 0 to 500. Most of my values are between 0 to 500, but one value is around 5,000. Okay. Out of suppose 10,000 entries, 9,999 entries are between 0 to 500, and one entry is 5,000, which is much different than the other values. So there could be two reasons for this. One reason could be that there isn't some error while collecting the data. And another reason is that actually the value went beyond the normal values. So I really need to understand what I am trying to collect, whether its value could be 5,000 actually. Is it an error? I really need to understand whether it is an error or it is actually some value which is beyond the normal value. If it is an error, I have to correct it, remove it, whatever I want to do. But if it is a value which actually occurred, so I have to be careful about that value. I have to be careful about that entry because that might lead me to some results which are important for me. I hope it is clear to you now. Please, if you have, it is clear to you, please write yes. Yes, Gopesh, thank you. Pathi also says thank you. So Gopesh didn't understand before, now he has understood, and that's good. Anybody else who has not understood this? Okay, Simran has also understood. Good, Simran. So this is one of the problem I have taken dealing with outliers. There are other problems in the data also. There are some missing values. Okay. There are certain missing values. I have not written here in this point is not there. So when we collect data, some of the values we are not able to collect or they were not there in that case. So we really need to see how we have to deal with these missing values. Okay, there are different ways of dealing with the missing values. Again, I say that you do not have to use one particular way of dealing with missing values just because you know that value. That normally when students do the analysis, I'm not talking about the experts. When students start doing these kinds of studies, and the easiest way of dealing with missing value is to remove that entry. Okay. Then again, you need to understand how it is going to impact. Maybe one attribute is missing, and other attributes are very important. So then we might need to deal with this missing value. Maybe there are different ways of dealing with this. One, as I said, is removing that value. Another could be putting 0 over there. Missing value, there are different ways of dealing with missing value. One is to remove that entry. Another is to use it 0 instead of the value. Another could be taking the mean of all the values in that row. Another could be taking a median of the value. So there are different ways of dealing with missing data. So whatever the data, whatever the missing value, however you are dealing it, you have to understand that why I'm dealing like this. If I'm putting 0, what is going to be the effect? If I'm putting the mean value, how it is going to affect it? Putting the median, how it is going to affect? Or if I'm removing the entry, how it is going to affect? So this is how you have to deal while what is we call as cleaning our data. So there are number of different problems. I have taken two of them, missing values or as I said is an outlier. There would be number of the things. So that is what we call as data cleaning. So rather than using that data, we have to clean that data And for cleaning the data, it is very important that we understand that data. Okay, each and every attribute you need to understand before using that in order to have good results. Otherwise, you will have some results you yourself would not be able to interpret them. Is it clear? Now, suppose another thing which you need to understand is I took some say about 50 attributes. I collected around 50 attributes. Okay. Out of these 50 attributes, some of my attributes would be I call as a dependent attribute and some would be independent attribute. So normally what is my output, what I really want in my output. Suppose I want to see, as an example I make certain measurements on my data. I'll show you one data after this. I make certain measurements on my software in my experiment, and I take certain measures. We call them as metrics. And out of these metrics, and what I am trying to find out that whether this class in my software, whether it is vulnerable to an attack or it is not vulnerable to an attack. Okay, my output is what I really want to find out, that whether some particular classes, which of my classes, suppose I have collected data about 1,000 classes, and I want to find out that out of these 1,000 classes, which classes are vulnerable to attack. And this I want to find out depending upon certain data, certain parameters which I have collected. Okay. So my dependent variable would be whether the class has vulnerability or the class does not have vulnerability. I can always write 1 if it has vulnerability, 0 if it doesn't have vulnerability. So that is my dependent variable, and rest all I call as my independent variables on which my dependent variable depends. Okay, so out of these 50 attributes, maybe there is only one my dependent variable and 49 are my independent variables. Okay, I'll show you some data also. I have understood my dependent variable. I have understood my independent variable, right? Now my independent variable. So now where comes the role of machine learning. Here comes when my independent variable could be, as I said, 0 or 1, means this class is vulnerable to attack or this class is not vulnerable to attack. Okay. Either it is vulnerable to attack or it is not vulnerable to attack. So what my result is, 0 or 1. Okay. So this kind of a problem, I say it is a classification problem because it classifies my output into certain classes. Fine. Then another kind of a problem could be where my output variable is simply a value. And then I say it could be some number, some value, which could be any value from say 0 to 2000, maybe any values, which I say is not a classy, it is not like binary numbers. Okay, continuous value. Then I say my problem is a kind of a regression problem. Another thing could be that my value is dependent upon the time. Then we call it as a time series analysis. So depending upon the kind of a problem you will have to have some modeling tool, and that model, whichever model you use, should be dependent upon what kind of output variable you have. Okay, so there would be normally, as today, if you will even check in the Google, there would be number of papers on security detection using AI and machine learning. Okay, so what they are doing, they are collecting data. They are collecting data about the vulnerabilities. They are collecting data. Many kinds of data is being collected, and depending upon that data, they are, before any vulnerability occurs, before any attack occurs, they predict that this if you have this kind of a value, then our attack can occur. If your input parameters are goes beyond this, your something might occur. So this class is vulnerable to attack. So we try to make a kind of, beforehand we try to predict whether our class is vulnerable to attack or not vulnerable to attack. So then we try to do this kind of a prediction. We call it as model. Well, we say it's the, we use some model, and there the role of these days model prediction normally these days is being done by machine learning techniques, and there the role of machine learning techniques come. So this is how I deal with my class. These days, we are also taking all classes online. This is the only way to make students wake up in the class. There is no other way. So now the role of what I said comes of the machine learning algorithms. So there are different machine learning algorithms. So you have an idea. There are two types of machine learning algorithms. One machine learning algorithm, basically two types, there are more also. If we start, we can divide it into two main categories. One we call as supervised learning and another we call as unsupervised learning. Okay, and when I talk of supervised learning, that means I have to teach machine by telling him the answers. Machine, I will say, I'll give him the training data, and in training data, answer would also be there. Okay. So when I give the training data to my machine, so I keep on telling 1 1 1 1 1 1, output is 0. 1 1 1 1 3 4, output is 2. 1 1 1 1 7 8, output is 1. So I give the input as well as output to the machine, and machine keeps on learns on that training data, and once it has learned on that training data, then next time I just give him test data but don't tell him the output, and now machine itself will tell me the output. Okay, so it is something like the way human brains occur, brain works. We keep on seeing some person, I keep on seeing some person, and then after some time when that person meets me, I can recognize that person. Okay. So similarly, machine keeps on learning. We keep on giving him the data also. I keep on telling that if this are the input variable, attack has occurred. If this was the input variable, attack did not occur. If this was the input variable, attack occurred. So I keep giving the input as well as output to the machine, and the machine learns itself. And after the machine learns, then I give him the test data. And when I give the test data, now I do not tell the output, and then I expect the machine to give me the right output. Okay, so I should have right output for all the data. So normally what we do, if I've got suppose my total data is 100 in numbers. So what will I do? I'll train it on 80 data, and then I will test on 20 data and see if for 20 data it is able to give me the right result or not. So this is what we mean by supervised learning. In unsupervised learning, I do not give him the output. The machine learns on itself by seeing the patterns in the data, and it makes some different patterns on its own. Okay, so that is what is unsupervised learning. Clustering kind of a things, they are applications of unsupervised learning. and in supervised classification normally is in supervised learning. So that is the main two types of machine learning algorithms. Algorithms are number. There are many number of algorithms, but these are the two main divisions of machine learning algorithms. I hope these are clear to you. It's not a simple job, but normally we have to understand already existing algorithms. Once we understand how these algorithms are working, and then we have to find out where, in which particular cases it is not working correctly and why. So when you understand why it is not working correctly, then we can think of what we can do in order to make it work better. If you will see on the net, you can just put in intrusion detection plus Arvinder Kaur. You put up my name along with intrusion detection on the Google. You will find a paper in which we have done intrusion detection by improving Firefly algorithm, which are the new types of algorithms which have come, which have been used today and have found to give better results than the earlier results. So you really you need to understand, you need to first go through a course on machine learning, understand them well, understand each and every algorithm, most of the algorithms, and then once you understand how they work, how they improve their results, how they change their weights, then by finding where this algorithm is not working correctly, we can think of certain improvements. Okay. Which algorithm commonly used? There are number of algorithms. Sport vector machine is one of them. Decision tree is another. There are number of algorithms. There are certain tools which you can use where those algorithms are already implemented. You can just do some parameter changes, and you can SPSS is one such tool. Veka is another such tool. You can also, there in Python also there are libraries in which these tools have many of these algorithms are implemented. Nowadays, from machine learning, we are also shifting to deep learning, where the problem set is large and it is more complex. We are using certain deep learning algorithms also. Convolution neural network is one which is being used these days for many of the problems. So J48 is another algorithm. If you will go in these tools, suppose SPSS or Veka tool, you will find the number of algorithms are there. But then again, for using any algorithm, you must understand it, that for which type of data this algorithm is suitable. Because if one algorithm works good for all kind of data, we would not have those many algorithms. We have those many algorithms because each algorithm works for certain set of data, better for certain set of data. So it is important to understand what assumptions are made while developing that algorithm, in which kind of data it works well. And that is why, and when we are not sure that which algorithm will work well, maybe 3-4 data which are similar, we can use those data to we can use those algorithm and see their results, and then we can find that for this kind of a data, this algorithm is working well. And then many times, even then, we do not get good results, and then we can think of improving those algorithms. As I said, if you will see in one of our papers, you can see many. In fact, in one of this paper, intrusion detection paper, some Firefly algorithm has been improved to get the better results. Okay. So yes, you will. It's not. I have made it very simple for you. But yes, machine learning algorithm, you really need to work. You have to study them well, understand their concepts, and then you can improve upon. And yes, if you really have an expertise, you have value in the market. Any other question? Any doubt? I think I made something clear. You asked for what are the algorithms available. Any other question? Should I move forward?
Somebody has asked about SEO, madam, search engine optimization.
Search engine optimization is something very different from this. Okay, for your interest, I'll say. I think we can take it then because it is not related to this topic at all. Okay, search engine optimization is you have to make certain changes in your so that your result come in the search when somebody searches on the Google, then we optimize our code in such a way that my website shows in the top 5, my website shows in the 5 top 10. So this is something which we call as search engine optimization. Combination of algorithm is possible in machine learning. Many people are using this. As I said, we improved in that Firefly algorithm again. That is again some combination of algorithms. Yes, people are using combination of algorithms, and there is some special term used for this. That term, I have skipped that term from my mind. It would come to my mind in few minutes. I'll get back. I'll tell you what is the term used. If you will, as you can see my paper on software maintainability prediction. You put software maintainability prediction plus Arvinder Kaur, if you will put. There we have used combination of algorithms. Getting old, so names skips. I'm not able to tell you the right name, what we call when we use combination of algorithms. It will come to my mind and sometime I'll give you that name. Yes, combination of algorithms are used when we feel that after using this improves. Another very important thing which I missed while talking about the data. So I took an example that suppose we have 50 parameters or 50 attributes, and out of 50 attribute, one attribute is my output attribute, and my output is dependent upon 49 other attributes, right? Now, training my machine learning on those 49 attributes is not a simple task. It would take time. And when I would like to predict also, again, it would require time. Okay, it will take more time, more resources. More resources, more time means money. And we want to do some optimization in this also. So one thing which we do is we also work on that area which we call as factor reduction. Is the name of the topic which we say. In that, what we do out of these 49 attributes, I really want to see whether these all 49 attributes are useful for my result or not. It might be possible that some of the attributes are interrelated to each other or are not improving my results. Okay, it might be possible that out of these 49 attributes, only if I use out of these 49 attributes, 10 attributes might be giving me the similar kind of a result rather than using those 49 attributes. So adding attribute is not a good thing. We really need to optimize the number of attributes required to give the kind of the result I am looking for. So what we do is we try to find out which attributes are giving me, there are different techniques for that. So what I can do, one of the technique I can explain you. Suppose I did a prediction with all 49 attributes and got certain results. Now what I do, now I remove one of the attribute which okay, how I remove is to be also made you understand. Okay, out of this, first let me say, suppose that with 49 attributes I got certain results. Then I remove one attribute and see whether my results are similar or have gone down. And if my results are similar, I might remove that attribute. How we remove the attributes, that is again a story. It's again a method which needs to be explained. But I just want to give a general idea that it is not good to have more attributes. We should have good result with minimum number of attributes, because minimum number of attributes means less cost, less resources. Is it clear to you? Am I able to give you my point? Please write in the chat if it is clear. Otherwise, I'll explain more. Jai says yes. 3, 4 more yes. Then only I'll move forward. Uday Pal. Thank you, Uday. Simran. Simran says yes. Okay. So although it is not, thank you, Gupesh. Thank you. Thank you. So it is not good to have more attributes. Sometimes when a new researcher or a new study you start, so what you say, I have added, because there were 50 attributes, now I have taken 60. So you might take 60, 60 are good than 50 only if they improve the result. We can have different combinations. You have added some. So we also have to look into the cost of doing the prediction and cost of doing all, because the effort versus cost has to be seen. Okay. So I think you have understood this also. We that what is the where the role of machine learning comes in these areas of when we try to do some kind of predictions. Okay. I move forward. Okay. Now you got certain results. I talked a little about this in the morning session also. Carefully analyze your data, taking into account the assumptions and limitations of the statistical test you use. I again said, now suppose my question is whether for this data set, I have used 5 machine learning algorithms. I used sport vector machine. I used J48. Suppose I also use decision tree. Okay, let me take 3 only. So I use these 3 machine learning algorithms, and I want to say which of these machine learning algorithm performed better for my particular problem. Okay. I used all these machine learning algorithms to do prediction, and maybe about okay, and I ran it over different data sets. Okay, not only on, I suppose I have 50 data sets, and on 50 data sets, I ran again all the 3 algorithms, and out of those 50 L times, my 20 times SVM performed, gave good results, and 15 times J48 and decision tree gave better results. Now, does it mean that SVM is better? Or as such, by just giving, because if I report like this, that because I had 50 data sets, and out of these 50 data sets, on 20 data sets, SVM performed better, and 15 and 50 data sets, J48 and decision tree performed better. So does it mean that I can say that SVM is a better for my this data set? Yes or no? Yes or no? I want answer in chat box. Jasmita says yes. Udaypal says yes. Mohandas says yes. Abhiraj also says yes. Jai says yes. Okay. Parthi also says yes. Unfortunately, statisticians do not say yes. Statisticians say that they have different kind of tests for these, depending upon the kind of data I have, there are different kind of tests available to ensure that actually 20, if SVM has performed better in 20, actually means that SVM is better. We have to do certain statistical tests. There are number of, do you have any idea of the statistical tests? If you have any idea, please write one or two statistical tests. If you have any idea, without Googling, okay, Simran? Without Googling, if you have, okay, Shresh says no. I want some more answers. Parthi also says no. One or two more answers would serve my purpose. Katnik say no. Jismita says no. Okay. So this is a very, please repeat the question. Yes. Uday, my question is, do you have any idea of the statistical tests which are performed on data to give statistically validated results? Is my question clear to you now, Uday? Okay. You have any idea of the statistical tests performed on data? Udaypal says yes. Can you write any name of any statistical test, Uday? No, it is not pie chart. No, they are not pie chart or flow chart. No, the security development life cycle model is a Google analyst. No, okay, I'll come. Uday, what you say is security development life cycle. That is the development life cycle model. That if we want a secure system, how we can, which software development life cycle model we can use to make this software development more secure. Okay, so that is very different than having some statistical tests on your data. They are something like t-test you must have heard of, Wilcoxon test. There are number of tests, uh, and these tests you cannot just apply on any type of data. Yes, it is something from data science. Yes, very true. So we have to see what kind of data we have, and depending upon the data, there are different kind of tests. There are basically two categories of test. One we call as parametric test and another we call as non-parametric test. Parametric test put certain constraints on the type of data we have. Non-parametric tests put less constraints on the type of data. So depending upon what kind of data we have to see whether it is data is what kind of data distribution is there, what kind of data, whether it is a normalized data, there could be different distributions of data. So depending upon what kind of distribution of data is there, we can apply different statistical tests, and after the result of statistical tests only we can say yes. If it is, maybe even if the SVM has given better results 20 times, my statistical tests might say that it is by chance only. SVM is as good as J48 and the decision tree and not better than that. Okay. So after finding the results, we have to apply statistical tests and then again get the results. And what again I have written at the end of the line, you can see, don't just rely on statistical text, but make careful judgment along the way. Again, you have to make a careful judgment that you can make only if you understand the whole process well, right from the data to the methods you have used for getting the results and the statistics test which you have applied to interpret the result. So it is not a one part. So empirical studies is not only one part, it is right from collecting the data. So you really need how we do experimentation, how the data collection is done, and then you also need to understand how we what kind of uh, algorithms we can use, and then you also need to understand data science to complete your study. I'm not just a minute. Yes, one another thing I would like to emphasize, that it is not always that you have to collect data. There are certain open sources where there are certain repositories of data which you can also use to work on your problem statement. As in the case I have shown in this slide, you can use Promise Data Repository, which has a huge data on many different problems, not only on security, on many other areas also. And there is this common vulnerability and exposure database. This is specially for vulnerability data. This is specially for security data. Okay. So from here also you can use the data given by other researchers, by other organizations, and you can work on that data and give your results, publish your results by working on those publicly available data. Okay, so privately we can collect the data. For that we can use certain tools. These are 45. These are the tools which are used in software security field. So you can use these tools. In there would be some freely available tools and open source tools, and there are some paid tools. So you need to arrange those tools, either open source or these tools which are available on charge. You have to arrange those tools to collect your data. As I have given some example, that 45 are some of the tools which are used in case of software security. These are some of the these are some of the terms which are again used in software security, which tells that any vulnerability, how severe is the vulnerability. This is how you measure actually the vulnerability, severity of the vulnerability. Okay, I'll not go into the details, but just to give you an idea, I'll explain one or two of these. like attack vector, which says whether a vulnerability can be exploited remotely, adjacently, locally, or physically. That means if to attack for this vulnerability, does the attacker can do it remotely, or it has to be nearby some nearby net or intranet, or it has to be in local intranet, or physically he has to attack from your system. So that gives an attack vector. So depending upon attack complexity, privilege required to attack, user interaction, what kind of authorization scope is required to attack, we can find the severity of vulnerability. And one of the problem in software security is also, we also predict that if the vulnerability would occur, what kind of security vulnerability it can pose, what kind of severity of this vulnerability would be there. Those of who are interested in looking into security topic in details for some kind of research problem, some kind of study problem, these are some of the journal names which are in the software security field. Computers and Security, Information Security Journal, International Journal of Information Security, Journal of Information Security and Applications, Security and Privacy, Transactions on Dependable and Secure Computing. So these are some general names which are in the area of software security, from where you can get more idea about what kind of work is being done in the industry or in the research in this field. If you really want to be serious, take up this profession seriously, so you really need to understand what is actually being done by Google, what is actually being done by Facebook, at what level they have reached in these areas. So you must know what are the journals where you should look in for. These are some of the top conferences in the area of security. Again, their publications are very helpful in order to understand this area in details, because it's a huge area. Again, some journals of software engineering which also cover software security. So these are the journals. They are software engineering journals, but they cover software security also. So these journal names I have to know. These are some of the databases from where you can get the data. You have any questions? Anything else, students, you want to have? Or should I?
Hello, ma'am.
Jasmita, yes, you want to say something?
Yes, actually, I want to learn about some statistical test types of statistical test used in data analytics.
There, Jasmita, it's a huge topic. You will have to read at least a book of 300 pages. Would not be easy to give me in such a small, but definitely you can go through my papers. There we have used many statistical techniques. You read a basic book,
Okay.
and then if you have any problem, you can speak to me or you can interact with me on net.
Mm-hmm.
Ma'am, can I please respond to this?
Yes.
Jasmita, we organize at Rajiv Gandhi National Institute of Youth Development periodically various programs on research methodologies, both qualitative and quantitative research methodology workshops we organize, even online. So which you may check our website from time to time, and you can apply.
That's
Okay,
very
sure.
nice,
These
because
are free
this is
programs.
basically overlapping with research methodology. This topic very much overlaps. Along with research methodology, we talk of machine learning in this, which is an extra thing, but otherwise research methodology is the same. Some
I'm
practical
not
based
sure
work.
I'm
Uday
not
is
sure
asking.
if Jasmita has applied for the next program on machine learning, which is
No,
going to
I
commence.
haven't.
In case if
No.
you are interested, apply for that.
Okay, sure, David. I will go for it.
Udaypal, you are asking for some practical based work or application links. There are number. If you will go through some papers in my even that intrusion detection paper, there are some tools given in that also which you can use. There is another paper I will give. It is the best. There are number of tools have been given. I do not have the list. Flaw finder is one such tool. Just let me see if I got the list right now with me. Those papers I don't have in print right now. I just try to see if I can share another screen. You can contact me on my email ID. I'll give you the list of the tools which are there, open source tools where on which you can work, and some sites also where you can get some data and you can start working on this.
Anything more the participants would like to ask the resource person?
Participant tired
I didn't get you. Okay. Thank you so much.
Right.
Thank you for
So
your
now
questions, hearing. They were all very good students, that I must say. They were all very attentive and actually very interested to learn. It is always a pleasure to interact with such students who are really interested to learn. Thank you, students. Thank you very much.